Let us discuss this example. In this example, we have some function, but we have t sine t by e raised to t whole square. We have to find its Laplace transform. What will we do? We will write that function properly first, and then we will think about how to solve this problem. Okay. So let me write so the function we have, that is t. I'm taking power of numerator and denominator, so sine square t divided by e raised to 2t we will have. So that exponential function we can shift to the numerator. So this is equal to e raised to minus 2t, power will be negative t, and sine square t, this thing we have. So that e raised to minus 2t you can take between t and sine square t also, but I am keeping it back. Okay, so that means what I want to do, first of all I will take Laplace of sine square t. After that t is there, that means effect of multiplication by t. You know that in that case we take derivative, so that thing we have to do first. And after that exponential function is there, that means shifting theorem is there, which is very simple. So whatever the difficult task we have, we do it first, and if you feel that particular task is simple, we will keep it for end. Okay, at end, so we consider that thing at the end. Okay, so in this way we will solve this example. Consider sine square t first. So Laplace of sine square t, see square is there, so that's why there is no any direct formula of Laplace to solve it. So I will use the formulas of trigonometry to simplify it. The formula for sine square theta is 1 minus cos 2 theta divided by 2. Let us use that formula. So Laplace of sine square t means 1 minus cos 2t divided by 2. So that 1 by 2 is a common denominator and it is a constant, so you can take it outside. So this is equal to 1 by 2 I am taking outside. So in bracket you will have simply 1 and cos 2t. So 1 is there, whose Laplace is 1 by s, minus cos 2t, whose Laplace is, you know the Laplace of cos 80, s upon s square plus a square. So by formula its Laplace will be s upon a square plus 4. Getting 2 square is 4. So minus sign was there, so that's why we took separate Laplace. You can further simplify, you can cross multiply. Let us see what will happen if you cross multiply. Okay, I'm simplifying it. So this is equal to 1 by 2. I'm going to cross multiply. So this is s square plus 4 minus, if you take product, s into s square divided by s square plus 4. So cross multiplication I have done. So what will happen, that s square and minus s square will get cancelled to each other. So at numerator you will have 4 only, and that 4 will get cancelled with this 2. 2 will get cancelled, and finally we will have, so let me write here, 2 upon, I will solve it, s cube plus 4s. So this thing we have by solving it. Okay, so right now we found out Laplace of sine square t only. After that we have to consider t. Then Laplace of t sine square t. So you know that when you have t or any higher power of t as a multiple of any function, we have to go for effect of multiplication by t. So that formula is very simple, minus 1 raised to n, and you have to take nth derivative of Laplace of neighboring function. So power of t is 1, so value of n is 1. So I am using the formula which we already discussed, minus 1 raised to 1. Here we have to take first derivative. Derivative of what? Laplace of neighboring function. Laplace of, what is its neighboring function? Sine square t, which we have already got here. Okay, Laplace of sine square t is that one, so that thing I have put there. So this is 2 upon s cube plus 4s, right? Okay, so when you take derivative and if you have any constants, we take it outside. So at numerator we have 2, which is constant, we can take it outside. So this is equal to minus 2. That means simply we have to take derivative of 1 upon s cube plus 4s. So I have already told you we have very simple and nice formula for derivative of 1 by x, which is minus 1 upon x square. Okay, many times we have already used this formula. So the same formula I'm going to use in this example also. So 1 by x, 1 upon s cube plus 4s, whatever we have. Okay, I'm going to use the formula. Minus 2. Formula says it is minus 1 upon square of denominator. Okay, same thing I have done. into again derivative of that denominator, since it is not a single variable, it is a function. So we have to apply chain rule and we have to take its derivative again. So its derivative will be derivative of x cube is 3s square plus derivative of 4s is 4. So this is a very simple thing we have got. Let us simplify it. Minus 2 into minus 1, 2. We will have 3s square plus 4s upon s cube plus 4s square. So this thing we have, right? So yeah, most of the thing we have done. So that means we found out a Laplace of t sine square t. So at the end we have to consider the last function e raised to minus 2t, and we have a first shifting theorem to solve that part. Okay, but there is no more space to write, so I suggest to make a screenshot of it, then we will go further. So the thing which we have got, I have written here. Okay, so Laplace of t sine square t we have got. So now simply we have to consider that exponential function. But before that I will simplify it more, and then I will consider an exponential function. What will I do? 2 3s square plus 4. See, what can we do? We can take s common again. Okay, so if I take s common, so we will have s, and if you take s common, we will have s square plus 4. Okay, by taking s common. But see that there is a bracket square, so I should take square of both terms. So if you take s here square and here square, so this is a thing which we have got. After that I will consider that last function, exponential function. So therefore Laplace of what we have to consider, e raised to minus 2t t sine square t. Okay, e raised to minus 2t t sine square t. So e raised to minus 2t, that means we have to go for first shifting theorem. Minus 2 is there, so we have to replace s by s plus 2. Exactly opposite sign we consider getting. So s minus 2 is there, so yeah, minus 2 is there, so I should replace s by s plus 2. Okay, here I have to replace s by s plus 2. What will you get? 2 3 s plus 2 square plus 4 divided by s plus 2 square. Here we will have s plus 2 square plus 4 whole square. Okay, we can further simplify. So let us do it. So this is equal to 2 3. I'm expanding the bracket. Okay, so s square plus 4s plus 4 plus 4. Am I right? What I have done, I have simply used a plus b bracket square formula, a square plus 2ab plus b square. That formula I use. Okay, here s plus 2 square, right? So here also you can use the same formula, s square plus 4s plus 4 and plus this 4. That means 4 plus 4 8 square, right? So this is equal to 2. So you can multiply each term by 3. So what will we have? We will have 3s square plus 12s plus 12 plus 4, that means 16, divided by s plus 2 square. So s square plus 4s plus 8 bracket square. So you can consider this as a final answer. Okay, make a screenshot of it, then we will stop. Thank you. Bye bye.